will prep for rational functions by looking at how to find the equations of slant asymptotes, but we won't actually find the equations of slant asymptotes. We'll talk about the steps you need to be able to find the equations of slant asymptotes, and the main thing you will need to be able to do is division of polynomials. So we'll remind ourselves about two of the techniques to divide polynomials. So the first thing is doing long division of polynomials. Now, I always read through the steps, but then it doesn't really ever make sense to a lot of students until you actually apply the steps multiple times, like see the steps. So the first step is to set with the division problem. The second step is to determine the first term of the quotient by dividing the leading term of the dividend by the leading term of the divisor. Next, the third step is to multiply the answer by the divisor and write it down below the like terms of the dividend. Next, step 4, subtract the bottom polynomial from the top polynomial. Step 5, bring down the next term of the dividend, and then the next, what you do after do that is repeat steps 2 through 5 until reaching the last term of the dividend. Now again, does that all make sense? Maybe not. Well, hopefully you have seen long division of polynomials, but if you were seeing that for the first time, you'd be wondering, okay, what on earth am I doing there? So let's actually do it with an example. Let's find the quotient and remainder for the following division problem. So we're dividing 3x cubed minus 4x squared plus 5x minus 2 by x squared plus x plus 3. So the first thing to do is to set up the division. So we're dividing x squared plus x plus 3, dividing that into the 3x cubed minus 4x squared plus 5x minus 2. Now, if there were any missing powers in the dividend, that's the one we're dividing into, then what many students would do is put spaces for those missing powers. Okay, so the next step is dividing the leading term of the dividend, the 3x cubed, by the leading term of the divisor, the x squared. So 3x cubed divided by x squared, that would be 3x. So let me put that up here. And then we take that 3x, multiply it by the divisor. So 3x times x squared would be 3x cubed. 3x times x would be plus 3x squared. 3x times 3, that would be plus 9x. And then we subtract that polynomial from the one right above it, just with the like terms one though. So the first terms, those of course cancel because the way we found this 3x was figuring out what do we have to multiply that x squared to get this 3x cubed. So of course those will be the exact same thing, so when we subtract them, they'll cancel. Then we have minus 4x squared minus 3x squared, so that'll be negative 7x squared. Then 5x minus 9x, so that'll be minus 4x. Bring down the next term of the dividend, so bring down the minus 2. And we'll repeat again. Take this negative 7x squared divided by x squared, that'll be minus 7. So we'll put that there in our quotient. Then the negative 7 times our divisor, so negative 7 times x squared will be negative 7x squared. Negative 7 times x will be minus 7x. Negative 7 times 3 will be negative 21. Subtract that. Again, like we're saying, the first terms always will cancel. Then we'll have negative 4x minus negative 7x, so that'll be negative 4x plus 7x, so that'll be 3x. Negative 2 minus negative 21, so that'll be plus 19. And now since the degree of this term is less than the degree of our divisor, we can't go any further. So what that tells us is what our quotient is in this case is the 3x minus 7. and our remainder is the 3x plus 19. And remember, if you wanted to write it using the division algorithm, that the 3x cubed minus 4x squared plus 5x minus 2 divided by the x squared plus x plus 3, that's equal to our quotient, the 3x minus 7. Oop. Something strange happened there, so ignore that. So it'll be the okay. Sorry, my computer is just having a little bit of a... Okay, there it goes. So it'll be the 3x minus 7, our quotient. Sorry, my computer is just acting really slow right now. Then plus our remainder, the 3x plus 19, divided by our divisor, which would be the x squared plus x plus 3. Now, how this relates to the equations of the slant or oblique asymptotes, let's say if this was our function, that this rational expression was our f of x, so f of x equals to this 3x cubed minus 4x squared plus 5x minus 2 all over x squared plus x plus 3. What it turns out is that the equation of the oblique asymptote or slant asymptote is the line y equal to 3x minus 7. It'll be equal to y equal to the quotient when you do your division. Now let's look at another case. If you remember, there was another technique for dividing polynomials which was called synthetic division. Now, synthetic division is a shortcut that can be used when the divisor is a polynomial in the form x minus a number k. So this is only for when you're dividing by like x plus or minus a number. So first, write k for the divisor, write the coefficients of the dividend. Step 3, bring the lead coefficient down. Step 4, multiply the lead coefficient by k, write the product in the next column. Step 5, add the terms of the second column. Step 6, multiply the result by k, write the product in the next column, and then repeat steps 5 and 6 for the remaining columns. Use the bottom numbers to write the quotient. The last number in the number in the last column is the remainder. Okay, once again, if you had never seen synthetic division before, which you should have by this point, then this would make no sense. But hopefully you should have seen it before. So let's just remind you with an example. So let's find the quotient and the remainder for the following division problem. When, let's say, if we have x squared minus 5x plus 3 divided by x plus 2. So in this case, our k is negative 2. Remember, we're dividing by x minus k, so our k in this case is negative 2. And then what you do, you put in this box the coefficients of your dividend. So the coefficient of the x squared, that was 1. The coefficient of the x term was a negative 5. The constant term was a 3. Then, like they said, next step, bring down the first term, so bring down the 1. Multiply the negative 2 times the 1, so you get negative 2. Add the two values in this column, so negative 5 plus negative 2 is negative 7. Then multiply the negative 2 times the negative 7, so you get 14. Add the numbers in that column, 3 plus 14 would be 17. So our remainder in this case is a 17. And our quotient, these are the coefficients of the quotient where the first term after the remainder is a constant, so that would be the negative 7. Then the next term would be the coefficient for the x, so that would be 1x or just x. And then if there had been more, let's say if it was like 2, then it would have been 2x squared, and so on. So this would be our quotient. And now again, as we were saying previously, how this relates to the equations of the slant asymptotes is that the equation of the slant asymptote for the function f of x equals to this x squared minus 5x plus 3 over x plus 2 would be the line y equals to x minus 7.